Welcome to my channel. This is Epicycloid, and what I do is solve technical drawing problems, and I provide very important information that you can make use of for you to have better performance in your technical drawing examinations. You are watching my video for the first time, thank you, and I want to ask that you subscribe to this channel, put on the notification bell so that whenever I upload a new video, you'll be notified, and help me share my videos to your friends who are technical drawing students. And it's very important that you practice this subject. When you practice it, you become a master at it. Right now, this is question 4 of 2023 WAEC paper 2 technical drawing. And as we have here that the sketch in figure 5 shows a circle of diameter 40 positioned at 45 degrees to the horizontal center line of another circle of diameter 140. Okay, so this circle here, its diameter is 40 millimeters, while this circle, its diameter is 140 millimeters, and we're asked to plot the locus of a point P as the smaller circle rolls over the circumference of the bigger circle for one complete revolution. Okay, or for one revolution. So this question carries 20 marks. Okay, now what we're asked to do here actually is to construct an epicycloid. So I want to show you how this can be done. So what we need to do first, as I'm going to do it here, is that we are going to draw. So we draw a vertical center line like this. Alright, so then we also draw a horizontal center line. So I put it down here. So we draw horizontal center line. So this is okay. So then the next thing that I'm going to do is to take my 45 degree set square, as we have that the angle at which this line is to the horizontal and also to the vertical is 45 degree. So we have to draw this line. So I'll just take my 45 degree set square, so set it at this point here. Set it at this point, and I will draw a line in this direction. Okay, so I may need to extend it, but I don't need to extend it, but let me extend it. Okay, so now, so the next thing that we are going to do, this angle, so this angle here is 45 degree. So this angle is 45 degree, as we see it in the question. So, and I will call this point, I will call it point O. So the next thing I'm going to do is to take a measurement of 70 millimeters, which is the radius of the big circle. The diameter is 140, the radius is 70. So I will take a measurement of 70 millimeters. 70 millimeters. Alright, this is 70 millimeters. So I'll put at this point O here, and I will draw an arc. So draw an arc like this. Okay, so the next thing I'm going to do now is to draw this circle. So the diameter of this circle is 140. So, and distance from this point to this point on the circle is half of the diameter of this circle is 40 millimeters. So distance from half of 40 is 20 millimeters. So I'll just take a measurement of 20 millimeters on my ruler. So take 20 millimeters here like this. So this is 20 millimeters. So I will put at this point here, and I will make an arc here. Okay, so this point that we have here is point P, so whose locus is to be produced. So with that 20 millimeters, I'll put at this point here, and then I will draw the circle. So it will touch this point, then I will go on and construct the circle like this. Alright, so that's it. So with this circle that I've produced, the next thing I'm going to do, I'm going to divide this circle. I'm going to divide it into 8 equal parts. So I'll divide into 8 equal parts. How do we do that? So with my 45 degree set square at this point, I will draw a line in this direction. Okay. Then, so making it vertical, so I will also divide this into 2 equal parts like this, and then so I will use my t-square to divide this into 2 equal parts. Okay, so into 45. Okay, so the next thing I'm going to do is to number this point. So I'm going to number this point. So this point is point 0. Okay, so this is point 1, this is point 2, this is point 3, so this is point 4, this is point 5, this is point 6, and this is point 7. Okay, so with the numbering that we have done, the next thing that we are going to do is that we need to do something that is very important. So we need to get the circumference on which this circle is rolling. The circumference of this big circle, or the big circle, though I didn't draw the whole of the circle, I don't need the whole of it. So I only need a part of it. So that's what I want to do. So we need to get the circumference upon which this small circle is rolling on this big arc here, which is for the big circle. So there's a formula that we need to use to get the angle that will give us that circumference, and this formula, the formula is written like this. So we have theta, so is equal to, so we have small letter r, that is the radius of this moving circle, and the radius of this big circle, that is capital letter R. So then we multiply this by 360 degree, and this is now equal to, so radius of this is 20 and the radius of this is 70, so times 360 degree. So according to my calculation, I think I have 100.1. Okay, what I actually got is 102. So I have to pause the video and check with my calculator. So 102 point, let's say 0.9 degree. So that's what I got. So I can approximate this to 103. So to 103 degree. So let's approximate like that. So now that we have gotten that angle that we are going, that's going to give us the circumference upon which this circle is rolling. So what we are going to do now is to take our protractor and get that 103. So I'll set it at this point O like this, and make sure the horizontal line on the protractor is on this line OP like this. Okay, then I will take that 103. So looking at this, so this is 100, then this is 101, 102, and 103. So this is 103. So what I'm going to do now is to draw a line from this point O here, and it goes like this. Alright, so now having done this, the next thing that I'm going to do is to divide. So this angle here, this angle is 103 degrees. So I'm going to divide this 103 degree, I'm going to divide into 8 equal parts, as we have divided this circle into 8 equal parts. So if I do that, so 103 by 8, so that gives me 12 millimeters, or 12 millimeters, or 12.8 millimeters. So we can just make it approximately 13 millimeters. So I just take it as 13 millimeters. So that's what I'm going to use, 13 millimeters. So that's what I'm going to use. So what I will do, or 13 degree, not millimeters, 13 degree is an angle, so it is 13 degree. So sorry for that. So I'll just take my protractor, I will set at this point and take 13 millimeters. So this is 13 millimeters here. Okay, so this is 13 millimeters. So then the next one will be 26 degree. So this is 26 degree. Okay, so that's how we are going to continue doing it. 13, 13, 13. So we take it until we get to this. So I'm going to pause the video, then I will come back where after I've gotten those points, then I will come back and show you the next thing to do. Alright, I've located the point as you can see here. The next thing that I'm going to do is that I'm going to draw a line through each of these points. So draw a line through each of these points. So this goes like this. Okay, so this goes like this. I divided it into 8 equal parts. So this goes like this, and then so this goes in this direction. So this line is not needed, so it's not part of it. So also, so I will draw this. So this goes like this, and I will also draw from here. Okay, then so we also have this one, so it goes in this direction, and last one is this, so it goes. Alright, so that is what we have for now. So now the next thing that we are going to do is that, so I'm going to number the point on this. So see, this is 0, so this is 1, this is 2, this is 3, so this is 4, this is 5, this is 6, this is 7, and then back to 0 here. Alright, so the next thing that I'm going to do now is to take my compass. So I take my compass, and then so I put at this point O here, and I will extend it to 1. I will extend it to 1. So this one, so it will also pass through 7. It will pass through 7. So as you can see here, so I will draw an arc like this. Okay, so draw an arc like this. Okay, then I will extend it to the center, exactly to the center like this, to draw the center arc. So it goes like this. So it's very important that you draw this. So it is just like you are constructing a cycloid. And don't forget that this is an epicycloid. What they ask us to construct is an epicycloid. Now I will extend it to 2. I will extend it to 2 like this. So 2 and 6, they are the same point. So I will draw like this, draw an arc like this. Alright, so the next is that I will extend to 7, to 3. So 3 and 5, they are together. 3 and 5 are together. So it goes like this. Alright, that's for 3 and 5. So the next is I will extend it to 4. Then I will draw an arc like this. Alright, so with all that we have here, so the next thing that I'm going to do is to label the center. So this is center C0 on the center arc. So this is this point. Then this point is C1. So this point is C2. This point is C3. So this point is C4. So this point here is C5. So this point here is C6. So this point is C7, and then this will be C0 here. Okay, so the next that we are going to do is to take the radius of the rolling circle. So this circle that is moving over this one. So we take the radius, that is 20 millimeters. So just take the radius like this, 20 millimeters. Okay. So and we put it at center 1 here on the center. So you have to take note of that. So we make an arc on line 1 or on arc 1 like this. Then we put it on center 2. So you make an arc on arc 2 like this. So make an arc on arc 2. Then we'll put our center 3 here. So we make an arc on arc 3. So by the time I put it at 4, so it will touch this point. Okay. So I need to, so it touch this point. So let me be noting those points. So this point here. So this is the point here. Then we have this point. So we also have this point for 4. Okay. Then I put our center 5. So I make an arc here. So let me take note of it. Then I'll put our center 6 here. Then make an arc on this line, on this arc. So we have this point. Then I'll put our center 7. So I make an arc here. Okay, so this is it. Then we are connecting together with this point O here. Also we are connecting together with this point here. So we take our French curve and we join this point together. So this is it. Alright, so we take it easy so that we can have a smooth curve. Alright, then I will join this from here. So connect this together like this. And I'll connect these 2 points together. Then these 2 points, I will connect them. Then I'll connect these 2 points together. Alright, so this is the locus of point P that we're asked to produce, and this curve is known as an epicycloid. It's as simple as I've done it here. All you need to do is to practice. When you practice, you become a master at it. Thank you and keep on practicing. God bless you.